What properties to be completed? Edric, what is the first property that we did?
Ma'am?
Yes. We were doing isosceles triangle and its properties. So what was the first property that we
Ma'am,
have
first property means
completed?
isosceles triangle has only two equal sides and two equal angles.
Okay. Two equal sides and two equal angles. All right. And what else? Then the sides equal, the sides opposite to equal angles are equal, right? And that angle is of an isosceles triangle, which are opposite to equal sides are equal. These properties we have completed. We have to start with the Pythagoras theorem. Now it is basically the property.
Good morning, ma'am.
Hi, Maya. Good morning. How are you now?
Much better, thank you, ma'am. How are
That's
you?
good. I'm good too.
What are we doing right now, ma'am? Could you just give me a quick recap what we have been doing the first two classes because I was absent?
Yes, Alana. So we had done the types of triangles. Okay. On the basis of their sides, the length of sides we saw scalene triangle, in which all three sides are different, isosceles with two sides are the same length, and equilateral in which all the three sides are of the same length, same measure. Now we saw the triangles on the basis of their angles. Okay, we saw acute angle triangle, which all angles are acute. Then right angle triangle, in which one angle is a right, and obtuse angle triangle, in which one angle is obtuse. Okay, then yesterday's class we talked about the properties of isosceles triangle. That is, we know that in isosceles triangle, two sides are equal. So the angles opposite to those two sides are also equal. Okay. Or if those two angles are equal, then the sides opposite to those two angles are equal. So those two properties we saw, and we did one question on it, on the property. Please go through the previous lectures on YouTube. Okay?
Okay, ma'am, thank you.
Yes, and today we are going to do properties of right triangle, that is Pythagoras theorem. Has Abraham joined?
No.
Okay.
Ma'am?
Yes.
Ma'am, I know the Pythagoras theorem. Ma'am, it is a square plus b square equals c square.
Okay. A square plus b square equals to c square. Yes, Edric. All right. Now we will make the diagram and we will do it. Okay. Make a right triangle. Let's name it triangle PQR. Q is forming an angle here. 90 degree. Okay. Now, suppose the measurement of sides are also given. It is 3 centimeter. And this 5 centimeter. Okay. So now TR, that is 5 centimeter, is called in a right triangle.
Hypotenuse.
Side, yes, opposite to the right angle is known as hypotenuse. Okay. The side opposite to the 90-degree angle, that is this PR in this triangle, 5 centimeter, PR side is known as hypotenuse. Okay. So my
It's
PR
known as what?
hypotenuse, Simeon. Okay, I'm writing it. PR 5 centimeter. What else have we given? Side PQ 3 centimeter. 3 centimeter. And the third side QR is 4 centimeter. We will do PQ square plus square of QR what is PQ? Again, 3 centimeter. And QR 4 centimeter. What am I getting? Solve it and tell me if it's true. $25. $25. Okay. Now, do the square of the hypotenuse. 5 centimeter. Do the square of 5 centimeter equals to 25. Okay. So this theorem says that the square of the other two sides is equals to the square of the hypotenuse. Okay. That is PQ square plus QR square is equals to PR square. Okay, so what we are proving that in a right triangle, square of hypotenuse is equals to sum of squares of other two sides. Other two sides. Okay, and this is the Pythagoras theorem.
Please don't rub it out, ma'am. I'm just writing it down.
Okay.
Finish copying, ma'am.
Finish copy. Okay.
I'm still copying 1 second.
Okay, copy it, please.
Ma'am,
Yes, Edric.
ma'am, does the Pythagoras theorem work only on right angle triangles?
Does the Pythagoras theorem work only on right angle triangle? Yes. Because Pythagoras theorem is basically the property of a right angle triangle. Okay. Because in a right angle triangle, you have the hypotenuse.
Okay, I'm done copying.
Okay.
Yes, ma'am. Now I'm exercising.
Alright. Okay, so if I have some questions right now. Hello, Abraham. Abraham, I cannot hear you. This is the question you have to try and solve on the property of isosceles triangle that we have done yesterday. Find the value of angle x. Find the value of x. Try this out right now, all of you.
X is equal to 120 degrees, right?
X is equals to 120 degrees, no signal.
Ma'am,
Yes, Archit.
x equal to 60 degrees.
Yes, very good. Think a little bit more, Sameer. You are close.
I don't know.
Yes, Sameer, what is it? Able to do it?
No, I couldn't get it.
So then that one. No problem. Let's see. Together.
Oh, wait,
how
now
to-
I got it.
Okay, you try first and then I'll explain. Okay. Abraham, if you're ready. This is not, you couldn't get Pythagoras theorem. Okay. See, it's basically a square plus b square equals to c square. Means that in a right triangle, in a right angle triangle, we have one side that is hypotenuse. Okay. Which side is the hypotenuse? The side right opposite to the right angle. Right, the side opposite to the 90-degree angle is your hypotenuse. Okay. So this now we have two sides and one hypotenuse in a right triangle. So when you do so the square of this two other sides, the sum of their squares will always be equal to the square of the hypotenuse. Okay, that is the side opposite to 90 degree angle. When you do it square, it will be equal to the when you add the other two sides, when you add the squares of the other two sides, those two will be equal. A square plus b square is the other two sides, and the c square is the hypotenuse. Okay? It's only just that the square of the other two sides equals to the square of the hypotenuse. Okay? Okay, let's try this out. Find the value of x. So in this question, it is an isosceles triangle. PQ side is equals to PR. This is given to us. Okay, so angle PQR PQR will be equal to angle PRQ. Why? See, this is the property of isosceles triangle that I explained yesterday. It's given that PQ side and PR side is equal. What is the opposite angle opposite to PR? This angle. Q is opposite to PR. What is the angle opposite to PQ? Angle R. That is, this angle is opposite to PQ. So these two opposite angles to equal sides are also equal. This is the property of isosceles triangle. Okay, so because of this property, we can do angle PQR equals to angle PRQ. Now we know that angle PRQ and PRS are angles on a straight line. Okay, and the total will be 180 degrees. Linear pair or angles on a straight line. Okay, so angle PRQ plus angle PRS is how much? 90 degrees. TRQ we don't know, but PRS we know. TRQ plus 120 degree equals to 180 degree. So angle PRQ will be 180 degree minus 120 degree. PRQ becomes how much? 60 degree. Okay. Now when PRQ is 60 degree, we just did that PRQ equals to QR. So angle PQR equals to angle PRQ equals to 60 degree. X equals to 60 degree. Okay. Hope you were able to get this. Hope you were able to
Yes,
understand.
ma'am.
Mama, I have a question.
Okay, yes, Ekta.
We will know by that it is an isosceles triangle by they putting those two marks, right, ma'am? So
Uh,
when we take the exam, ma'am, we cannot
Mhm.
assume it's an isosceles triangle, right, ma'am? We have to find the marks and then only we can say that okay, this is an isosceles triangle, right?
Yes, you find the mark and then you can tell that it is an isosceles triangle. If the mark was like this, then what triangle? Equilateral triangle. Okay. If the mark was like this, that a straight line on all three sides means equilateral. On two sides means isosceles. If no line is there, scalar triangle. Okay. Even by looking at the triangle, you can tell that if it is isosceles, you can see like that two sides are equal. You can see that. Okay, equilateral. You can see that three sides are equal.
So, ma'am,
Right.
actually the question is because that an isosceles triangle has like one, two. So, like in the question paper, they say that by looking at this triangle, find the missing angles. So, like, if the question says that, then what do we do? Well, it looks isosceles, but there are no marks. So, should we take it as isosceles or scaling? I'm not understanding that.
Abraham, if you take a look at an equilateral triangle, you will be able to see that all the three sides are equal. Okay, it will look like this, a proper triangle. You'll be able to look and tell that three sides are equal.
So, then what are
But
the angles of 60 degrees?
scalar triangle always looks a little weird. Okay. Means that you'll be able to tell that all three sides are in a scalar triangle. You will be able to tell.
Okay, ma'am. So, without even having the marks, we can tell, right, ma'am?
Yes, we can tell by looking at it. If it is isosceles triangle, you will be able to tell it will be shaped like somewhat like this. Like you'll be able to tell two sides will appear to be equal. One side will be short or long. So you will be able to tell by looking at it. Mostly the marks will be given. The marks are given most of the time. Even if not, you can tell by looking, or if you cannot tell by looking, measure with, take the scale, place it on the sides, measure it if you are getting two sides equal or three sides equal or all sides are equal. Okay. All right. One interesting question we are going to do right now. Okay. Draw right triangle. Now, in this triangle, PQ and QR are equal. Right triangle and isosceles triangle. This is X. Can you find out the value of angle X?
Yes, ma'am. I know, ma'am.
Yes, I do.
Ma'am, it's 45.
Yes, very. I'm giving you all some time to figure it out. Okay, everyone, please try it out. We know that the sum of all angles of a triangle is 180 degrees. And just now we saw the property of isosceles triangles. Okay, so according to that, try to figure this out. Yes, that's right.
Ma'am, a 90-degree triangle is a scalene triangle, is an isosceles triangle, right?
90-degree triangle is an isosceles triangle.
And
In this case, it is yes, but in some cases, it might not be.
thank you, ma'am. Ma'am.
And okay, all right. So let's see why is this happening. Okay, so in the question is given that PQ is equals to QR. Okay. Therefore, angle P will be equal to angle I. Why? Signs of angles oppositely equal, signs are equal. angles opposite to equal sides are equal. I will quickly make and show you. See, this side, what's the angle opposite to R? QR.
Ma'am, P.
This angle. This angle. Okay. What is the angle opposite to PQ?
R.
Yes. This angle. That is why P and R are equal. Okay. Then, what is the sum of all the angles of a triangle?
Ma'am, 180.
180. Yes. It's 180. So we can do angle P plus angle Q plus angle R equals to 180 degree. Angle P and angle R we don't know. X plus Q is 90. Angle R also, if P is X, then I can say that R is also X. Okay, because both are equal, right? So R we can I can say that R is also X plus X equals to 180 degree. So 2x plus 90 degree equals to 180 degree. 2x equals to, we'll take 90 that side, minus 90.
2x equal to 180 minus 90.
Yes. So 2x equals to 90 degree. Then x equals to 90 degree divided by 2. 3 ones are 45. Okay. Then x equals to 45 degree. So my angle R and angle P both will be what? 45 degree. Okay. 45 degree and 45 degree. Because why? Because angles opposite to equal sides are equal. Okay. Hope you got it.
Ma'am, finish copying, ma'am.
Finish copy.
Okay.
Okay. Any doubts?
We just think you just divided 90 by 2 because
Yes. Yes, Abraham. 90 by 2.
just 90 is 90.
You can just divide 90 by 2. Okay. This is a property of triangles. When you are adding all the triangles, the sum of all the angles of a triangle is 180 degree. This is known as angle sum property. This thing, okay, is known as angle sum property. Okay. Sum of all the angles of a triangle are 180 degree. We did this previously. Sum of all angles of a triangle is 180 degree. Angle sum property. Okay. All right. So we have finished with chapter 12. Okay. Chapter 12 is done. And I'll keep a test soon of this chapter, let you all know. Okay. Keep a test of it. And if there's any doubts, please solve this chapter. Please complete all the exercises of this chapter. If there's any doubts, just ask me in the upcoming classes. All right. Please ask
How
me in the
many,
upcoming
how
classes.
many exercises are there in this chapter, ma'am?
How many exercises are there in this chapter? the last exercise is 12.7. Let me just open and see. Yes, 12.7. That is your homework for today. Two questions are there in that exercise. 12.7. 12.7 is the homework. Please finish all the exercises and ask your doubts. All right. We'll stop here. Okay. And okay, Ajit, I'll see you in the next class. Bye.
Bye, ma'am.
All right. We'll be starting with science class. Okay. So 2-3 minutes break is there till 8:25. 3
Ma'am, I
minutes.
just had to tell you something.
Yes, Anaya, what is it?
I haven't yet done the maths chapter 11 test. I'll do it today and I'll send it to you. Okay?
Okay. Okay, Anaya. That's all right. Okay, hope you all are there. Yes, we are about to start. Carry on, please. Yes. So in the previous classes, we started with the 17th chapter, light. We finished off with sound, with noise, noise pollution and all that. We started with light. Okay. And light is basically an energy, okay, that allows us to see, various objects. When we talked about sources of light, there are some natural sources that are there, okay, like sun and the stars, how there are artificial sources which also give light, okay, such as candle lamps and all, which are man-made. We talked about luminous and non-luminous sources. The sources which have their own light are luminous sources, like sun, stars. Those who do not have their own light, okay, are non-luminous. We talked about sources of hot and cold light. Hot light means when with along with light, heat is also produced. Cold light means heat is not produced. Then we talked about the frequency of light sources. Some have more shine, some have less shine. These are the categories of non-luminous objects: transparent, translucent, opaque. If now suppose I have a torch here, okay, and it's turned on. Light is passing through. Okay? Light is emitting from the torch. If there is a glass pane, a glass pane, transparent glass pane, the light will go through it. Okay, the light will go through it. It will travel through it. But if there is a translucent pane, since a translucent pane, then only sunlight will be able to travel through it. Sunlight will be able to travel through it. What if it is opaque, wooden box? What if it is a wooden box? This is a wooden box. Light will not travel through it. Why? Because this wooden box is opaque. Opaque. And light does not travel through the opaque objects. It will create a barrier for the light to pass through. Okay, it will work as a barrier, opaque objects. Light will not travel through the opaque objects to the other side. All right. So these three categories we studied about: transparent, translucent, and opaque, and how light
I
travels.
didn't hear the last part that before translucent and opaque.
Before translucent and opaque, the first part, that is transparent. That one, something.
No, before also that.
Before that, I was just giving a recap of what we studied yesterday. Right?
Okay.
That was it. Yeah. Okay. So now, then we talked about traveling of light. We talked about traveling of light. Okay. Now there are light travels in various mediums. Okay, various mediums means in various things, in various types of spaces, like air, Okay, another medium is water. Another medium can be an object such as a diamond or something. It can be vacuum. Okay, it can be water. It can be an object. Those are all mediums, okay, through which light travels. One image I want to show you. Just give me a minute. You see this speed of light. So we have talked about it. This light travels fastest speed in vacuum. Okay. Then a bit lesser than that in water. Then a bit lesser in glass, light travels, okay, in the glass medium, and then even lesser through diamond. Okay. So this is distance traveled in 1 second. In vacuum, it's 1,86,000 miles. Okay, we studied in kilometers in our textbook. It's in kilometers. Okay, the same thing. So in vacuum, it is the highest. In diamond, it is the lowest. Okay, the traveling of the speed of light at which it travels through these mediums. Okay, and just a second. Yes. So then we have another thing that is reflection of light. Now we know that, like I explained in the last class, what did I say? That light travels in a straight line in a medium. Light travels in a straight line in a medium. This is water, a medium. And in the water, the light will travel in a straight line. In vacuum too, light will travel in a straight line. Okay. The light travels in a straight line, in any medium. Okay. And when we are drawing like lines, okay, sorry, when we are drawing lights, we draw it using a straight line symbol with an arrow. This way we draw the light, denote the light in diagrams. Okay. So, a straight line with an arrow in the end is called a ray. A group of many rays is called a beam. Okay. A group of many rays is called a beam. First, we have parallel beam. Here, all rays travel parallel to each other. This is how parallel beam looks like. Okay. All the rays are traveling parallel to each other. Convergent beam. This comes from many directions, which focus it on the middle point. I will show you. This is the convergent beam. This is a middle point. This part is the middle point. Okay, it's coming from different directions, but they all are coming at one point only, falling at a one point only. This is convergent beam. Then this is divergent beam. Okay, means that it is going from one point only in different directions. Okay, going from one point only in different directions. This is divergent beam. Okay. This is that collection of light rays which originates from one point and then moves in many directions. Okay. When light traveling in a medium when light traveling in a medium collides with any object, then the speed of light according to the nature of the object can be when light in a okay. So suppose light is traveling and it collides with an object. So some light is expanded and some light is absorbed if this is opaque. Okay. But if there is a transparent object, it will absorb some light and some goes back and some goes through it. Okay. If this is a transparent object, some light will go through it, some it will absorb, and some goes back. Okay. Sometimes we can see our face in the window pane. This happens because of window mirror where some light is absorbed and some light passes through the object. Glass pane also absorbs some light. Okay. So a glass or a transparent object, they absorb some light, some is passed through it and some is traveled back. Okay, three things will happen in a case of transparent object. If the object is greasy and shiny, it cannot absorb light. The maximum light goes back after collision. Okay. This process of light going back after collision with a layer of an object is called regression. Due to light regression, we can see own images and image of other objects in a mirror, steel utensil, and other objects of shining surface. Okay. Alright, so rules of regression. We will meet and we will see. Okay. So, basically, reflection, regression is a kind of reflection only. Okay. And what happens? Is, suppose I am having a mirror. This is a mirror. Okay. And the light ray is falling on it. Okay. And then it is reflected. This ray falling on it and then reflected. Ray falling on it is known as incident ray. The ray reflected is known as reflected ray. Okay. Reflected ray. Alright. Now, what happens? What is reflection basically? The process due to which the light falls on the surface and gets bounced back. Okay, this is the surface of a mirror. Okay, the light is falling and then reflected. Okay, and bounced it is getting bounced back. That is reflection of light. Okay. And now there is one line in between these two that is perpendicular on the surface. That is perpendicular on the surface. And it makes two angles. One with the incident ray, one with the reflected ray. One with the incident ray, that is here. One with the reflected ray, that is here. This is angle I. This is angle R. Means angle of incidence and angle of reflection. Okay. So what is an incident ray? The ray of light that straightway falls on the reflecting surface, okay, from the object or a source. That is incident. That is directly falling on the reflecting surface. What's the reflecting surface? The mirror. Mirror is the reflecting surface. Okay. And incident ray directly falls on the reflecting surface from the source. What is the reflected ray? The ray which reflects back after striking the reflecting surface. Is the reflected ray. Incident ray strikes the mirror and then it got reflected up. Okay. That is reflected ray. What is angle of incidence? Angle of incidence. This is center point is known as normal. Okay. What is angle of incidence? The angle it will form between the incident ray and the germ ray at the point of incidence known as the angle of incidence. Angle of reflection will form between the perpendicular and the reflected ray. Okay. All right. What is this normal named line in between? This line is perpendicular to the reflected surface. What does it do? It acts as a separation between the incidence and the reflection. Okay. Separation between, okay, this is the plane of incidence. This is the plane of reflection. It separates them two. So your angle of incident is made on one side, angle of reflection is made on the other side. All right. Hope this part is clear to you. Any question?
So it's the same angle on both sides.
Yes, Anian. So here, angle I, that's angle incident, angle of incidence is equals to angle of reflection. Okay. Angle of incidence is I equals to angle of reflection. That is R. Okay. Hope this is clear to you. Okay. I'll be providing you some good notes for this reflection part basically. Okay. In our book, it's very limited and basic thing given, but we will do it in a more like we'll do the laws, we'll do the types of reflection. Okay, we'll do this topic a little bit more detailed because it's a very important topic. It's essential for us to understand why is it happening, what's basically the incident ray, reflected ray, what are the two types of reflections and all of that. Okay, I'll give you good notes for this topic. All right. Whatever I am doing here right now, I'll be giving the notes to you. Okay. All right. So now we have the two types of reflection that I just said. Okay, shall I erase this diagram?
Yes, ma'am.
Okay. All right. So there are two types of reflections. Regular reflection and diffuse reflection. Okay. So let's do the first one, that is regular reflection. What happens? Suppose I have a mirror or a smooth plane surface. Hmm, okay. Hmm. So my incident ray will fall on it. Incident rays will fall on the surface and my reflected rays will get reflected. Hi Abraham. Just
There's a feeling of it, ma'am.
you thought the class was over.
Sorry, ma'am, I got late now. Everybody left, ma'am, so I thought no science class.
No, they were there.
Anaya left, Singing left, you left, so I thought no science class anymore.
No, they were there. All right. So, I'm teaching reflection right now. Okay. And I'm doing the two types of it. That is regular reflection and diffuse reflection. I'm doing this is regular reflection. Okay. And you can go through the whole thing on I'll be sharing the link of this class. So go through the previous part that I have covered. Also, Abraham, I'll be sharing the notes of this reflection topic, more detailed and good notes. This is incident rays. Incident rays. This is reflected rays. This is your smooth surface. Or a mirror. Okay. So what is basically regular reflection? It is created by plane mirror with smooth surfaces. Okay. But the incident rays that are falling on it on the surface will reflect equally in a uniform manner. Okay. Equally, it will reflect equally in a uniform. Can you see the uniformity here? Like the way they are falling, that way only they are reflecting. Okay, there is a uniformity. They are reflecting equally. So this is known as regular reflection or specular reflection. Okay, so writing it, it's created by plane mirrors with smooth surface.
Ma'am, I have a question, ma'am.
Yes,
It's because of light rays we see color, right, ma'am?
yes, plane mirror with smooth surface. reflected equally in a uniform manner. This is regular reflection. The opposite is the irregular reflection, and that the rays do not get reflected in a uniform way, in an equal way, but more in a diffused way. More in a The reflected rays will be more diffuse. They will not be uniform like here. We'll draw its diagram and we'll see. Okay. Just let me know once you are done this. Okay.
Okay, ma'am, I understood now.
Yeah.
The of the ray when it comes in a certain angle.
Mm-hmm. The rays, it is the matter of the surface on which it is falling. If it is a smooth surface of a plane mirror, they will get reflected in the same way. If it is an irregular surface, then it will be diffused. When it falls on an irregular surface, it will be the reflected rays will be diffused.
Ma'am, by
Not
diffusing,
yes, Abraham, can you repeat?
by diffusing, like, will they like scatter?
Scatter, yes. Yes, they will scatter more.
So, ma'am, that's when you have like a irregular mirror, like in the fun houses, they keep those irregular mirrors, that irregular mirrors that because that they scatter your face, so your appearance looks weird.
Mm-hmm. Yes, irregular mirrors, they will scatter. Irregular mirrors, they will scatter. Shall I remove this and move forward?
Don't know.
Okay, another done. Okay, I'm going to clearing it. Done, ma'am. Thank you. Alright. Then let's see the other one, that is diffuse reflection or irregular reflection. Okay. Now, in this reflection, suppose I have an uneven surface. Suppose I have an uneven surface. Okay. Let's take the rays of incidence.
So in water, the light will bend, but it won't reflect.
It will reflect, but in an uneven way, like this. In an uneven way, it will reflect. This is the incident.
But why?
But why? Because the surface is uneven. Okay. Now, when the light reflects from a rough surface, they get diffused. Like they reflect in an erratic manner, and because of this, the brightness and the reflection quality both gets diminished. Okay, the brightness of the light and its reflection quality, how well it's reflecting, that all gets diminished.
But supposing like the the surface of the water is completely still, there's nothing shaking it, not even vibration, then will it come normally?
Then, if it is completely still, not even shaking, then yes, I think it will come as a regular reflection. But if it is irregular, if it's shaky, if it lays there, then it will be slightly diffused. Okay, that
And
depends on the surface.
also
Yeah.
in water, light can pass through water. So won't the light go to the bottom of the water and then only reflect, or will it reflect on the surface?
Simeon, like I just explained, there is it will go to the bottom, some of it will reflect on the surface, some of it will be absorbed too. All the three things take place. Okay.
Okay.
Some of it will go through it, that is to the bottom. Some of it will get reflected over the surface. Some of it will be absorbed. Three things will take place. Okay, this is incident ray. This is reflected rays. Reflected rays. Okay. Now, light reflects from the left surface. This is rough surface in an uneven or erratic manner. And the reflection quality is diminished. Okay. Hope the two types of reflections are clear, regular reflection and diffuse reflection. In your book, the laws of reflection are given. Okay, on a plane surface when lights fall, two laws are given in it, but this is not mentioned, the types of reflection. How the incident rays fall on the different types of surfaces and how it gets reflected. So notes I'll be providing for it. Okay? for the laws for reflection, its types, the formula, and everything. Notes I'll take it in forward. Any doubt? Any question? In the type of reflection?
No.
Okay. Please write this down and let me know when you guys are done. So we will complete it. Done? Okay. We'll do the laws of reflection in the next class. Okay. Abraham done?
Ma'am, all
Okay, do it. You can write it down. Okay, senior. Okay, then, see you all both. See you both in the next class.
Thank
Bye.
you.
Thank
Bye.
you.
Bye. Bye.